Moving on. So in the last video, we took the spot rates and priced coupon bonds. Now we want to go the other way. Given various coupon bonds with some extra information, like prices, can we extract the yield curve? Well, the answer is yes. We use something called bootstrapping, and it's a recursive process. So here's an example, right? We've got 4 bonds. All coupon and yield to maturity rates are nominal, annual, convertible twice per year. So we've got 4 bonds. One matures in a half year, another in 1 year, another in a year and a half, and another in 2 years. We have their coupon rates, and I could give you you could be given the prices for each of those bonds, in which case you can find their yields to maturity, or you can just be given the yield to maturity, which is YTM. So in this example, we're given YTM, but you use the financial calculator to find YTM if you need to, if you're given the prices. So our task is to find the associated term structures for zero coupon bond with maturities of half year, 1 year, 1.5 year, and 2 years, with a reminder that quotations should be nominal annual rates convertible twice per year. So as I mentioned, this is an iterative, recursive process. So we start with bond number 1, and then we get information, and then we use that to get bond number 2 to get the next piece of information, and so on until we get to the end. So starting with bond 1, this is essentially a zero coupon bond, right? And the reason is because there's only one payment. You get your coupon plus the redemption amount all in 6 months. So the yield is equal to the spot rate. So our first spot rate as a nominal annual rate convertible twice per year is 5%. Now, I do want to say a word before we go on to the next one. I didn't give you a face value. And that's because when we do these calculations, the face values are going to cancel so we can use whatever we want. So in the calculations, I'm going to use a face value of 100 because that makes the number simple. You could also use a face value of 1 if you don't mind working with the decimals. So moving on, we have S0, we have S of 0.5, now we want S of 1, and we use bond 2. There's a typo, setup. The setup, we set up and solve an equation for S01 using the information about the second bond. So we price the bond using S05 and S01. Right? So how does all this work? So the price for the bond maturing in 1 year is 96.28, right? We can get that from the yield to maturity here, right? We have 1 year, we can go ahead and assume 100 in face value, right? And then put in, that means we get 2 coupons of 3, and the last coupon comes with the 100, and we price it to yield 5%. Right? We can do that in the calculator, and we get 96.28. At the same time, that should be the same price we get if we price using the yield curve, of which we know at least one piece of information. So what does that mean? We know S0 of 0.5 is 5%, meaning the rate is, as an effective semi-annual rate, is 2.5%. So we've got the price using the constant, the effective yield, 96.28, and we have the price using the yield curve, and we simply equate them. Now we have a 1 variable equation with 1 unknown, and we solve it for that unknown, and we get 5.039% as an effective rate. So as a nominal rate compounded semi-annually, remember we have to double, 10.078%. And now we just repeat the process. Right? So now we have 2 spot rates, 5% for 1/2, 10.078% for 1, and we also have the information about the third bond. So with the third bond, again, we'll continue to use a face value of 100. We have a yield of 15%, 3 coupon payments of 20. Remember, semi-annual coupons. And at price to yield 15% compounded semi-annually, the price we get is $85.70. That's the price using that yield rate of 15%. Now we price using the spot rates, the term structure. Well, we know the 2.5, so the coupons are 2, as we know. The yield rate, the spot rate for the first payment is 2.5%. From the last part, the spot rate for the second payment, now we use the effective rate, 5.039%. And the final, redemption plus last coupon of 102, is discounted using our last unknown yield rate. So now we've got price using the yield, the yield rate for the bond, price using the term structure, unknown with our unknown spot rate. Solve for the unknown spot rate, we get 7.574%. And as a nominal rate, we double it to 15.15%. Now we move on to the last one. Right? So the bond maturing in 2 years has coupons of 4 payments of coupons of 4, the last one accompanied by the redemption. Price to yield 15% compounded semi-annually. Price it in your calculator, and you get 88.28 priced using the bond's intrinsic yield rate. Now we price using the yield curve with everything we know and everything we don't know, solve for what we don't know, and we complete constructing the term structure or the yield rate. And that's it. It's tedious depending on how far out you're going to construct your term structure, but it works. In the next video, we're going to look at an interesting problem where the information we're given is not enough to extract the yield curve, but we can answer the problem by creating something called a synthetic zero bond.